So we've got three different sections we're going through today, 511 through 513. So we're going to start with ecological footprint, which is the measure of land that is used by an individual or a group. So we're going to talk about how that's calculated and ways we can lower that. Here's your essential knowledge and your learning objective. For our FRQ, you're going to explain what the data implies or illustrates about environmental issues. So like I said, it's just a measure of how much either a person or a group is going to consume expressed in area of land. So this diagram over here is pretty good because when we talk about this and we say an area of land, you also have to think about like the amount of land that's required to grow your food and things like that. So we've got energy that we have to account for, our houses, materials we use, the food we eat. So lots of things go into your ecological footprint. So we're going to need land to produce our food. We're going to need land to produce raw materials, wood, metal, plastic that make up all the consumables that we have, your house, electricity production. So whether we're talking about coal and natural gas or even things like solar and wind, that's still going to use these raw materials that have to be extracted for us to use them. So even if you are using like renewable electricity productions or energy sources, you're still going to have to account for the raw materials that go into those. And then we also have to make sure we account for our landfill space for whatever amount of waste we create. So, like I said, the ecological is going to be measured in land. So that's a global hectare. And so that's a biologically productive hectare. A hectare is equal to about roughly 2.47 acres. And so our ecological footprint is a little bit different from our carbon footprint because our carbon footprint is measured in tons of carbon dioxide produced per year. So numbers like this is what you'll see. The lower the number, the less footprint you have, the higher the number, the larger of a footprint you have. So when we look at our carbon footprint, we're just looking at all the carbon dioxide that's released from an individual or a group's consumption or activities. And we've got to think of a lot of different things here. So with material goods, we have to think about the shipping process, packaging, manufacturing, all those things. Food production, we have to think about, the tractors that are used to plant and harvest. Those are going to release carbon dioxide. Energy use, so gas, heat, electricity. We have to get the source to be able to do that, whether it's gas or coal. We have to get those materials, and that's going to release carbon dioxide. So some things that are going to affect your carbon footprint, the wealthier you are, that's going to increase your carbon and your ecological footprint. And that's because when you tend to be wealthier, you tend to have a larger home, you travel further, and you just use more things. Meat consumption is another one because if you remember back, meat to have meat for production for us to eat, that takes a lot more land and water and energy than it does to create the same amount of protein from a plant. And then we also have fossil fuel usage. So the more fossil fuels you use, the higher your footprint will be. So heating your house, keeping your house set really hot, your electricity, not turning your lights off or unplugging things, traveling, plastics, all those things use fossil fuels. And then some ways to decrease that footprint would be to use renewable energy sources, even though they do release some carbon dioxide in the creation of them. Over time, they release less than, coal or gas would. Public transportation, that's going to use less gasoline. A plant-based diet, and then just buying less things or trying to buy things secondhand as opposed to brand new, traveling less, and just overall using less energy. So making sure lights are turned off, making sure things are unplugged, things like that. So when we look at the ecological footprint, we can also look at it in terms of number of Earths. So that means how many Earths would be required if the whole world, everybody in the world, consumed the same level of resources as any one given individual or group. And when we look at the United States, the current average footprint in the United States is 5.1 Earths. So that means that if everyone in the world lived like people here in the United States live, we would need resources from over 5 Earths to be sustainable. We would use that much material if everybody lived like we do. So it's a lot. And to put it into perspective, the current global footprint on average is only 1.85. So much lower than the United States of 5.1. So that means that that's still not the best though, because that means that every year we're consuming 1.85 times what the Earth can produce in 1 year. So we may have an excess that we're using from years past or things like that, but we're still using quite a bit more than what the Earth can supply. So your FRQ for today is to describe one factor that accounts for the difference in the carbon footprint between the United States and Uganda, and you need to explain one environmental consequence of that factor. The next section we're going to look at is 5.12, which is sustainability. So we're just going to talk about what does sustainability actually mean and how can we know if we are living a sustainable lifestyle. So here's your essential knowledge and your learning objectives. Our FRQ today is to explain what the data implies or illustrates about environmental issues. So sustainability essentially just means that we're going to use a resource or a space in a way that doesn't deplete it or degrade it for future generations. So that means we're leaving the environment, we're leaving the resource intact for our children, our grandchildren, great-grandchildren, all the way down the line. So an example of that would be, instead of using synthetic fertilizer, which relies on fossil fuels we know will eventually run out, we could maybe use compost instead as our fertilizer because that is renewable. We're always creating and generating food scraps and food waste that can be turned into compost. So the maximum sustainable yield, this is one thing we have to look at when we are trying to determine the sustainability of a, what word am I looking for? Of an action. So that's the maximum amount of renewable resource that we can take without depleting it or reducing it for future use. This tends to be about roughly half of the carrying capacity of a population. And this is going to maximize yield, so the harvest we can get, so we can get more money, and the regeneration rate. So when you look at this diagram, if our carrying capacity is right here, if we were to harvest all the way back down here, we're not leaving very many things behind. We're going to be losing some genetic biodiversity, and that's going to cause the population to have a hard time regenerating. If we cut all the way up here, we're not harvesting very much. That's not going to be very profitable for us. But if we harvest at about half of that carrying capacity, that's when we're going to be able to allow that population to regrow and still get enough for it to be profitable. So we've got some environmental indicators of sustainability. So some things that we look at to determine if things are actually truly sustainable or not. So these are going to help guide us to become more sustainable and tell us a little bit about the health of the environment. So the first one we're going to look at is biodiversity. So that's going to include all 3 levels: genetic, species, ecosystem. Remember, the higher biodiversity we have, the healthier ecosystems we have. The more genetic biodiversity we have, the more resistant and resilient those populations will be. The more species we have, that's going to allow us to have a more complex food web, or ecosystem where things are surviving, and then the ecosystem biodiversity is just providing different habitats. So if we have declining biodiversity, that can show us that we have pollution, we have habitat destruction, we have climate change, and none of those are sustainable actions. So right now, one good thing we can look at a good piece of data we can look at to determine this biodiversity is the global extinction rate. That's a very strong indicator, since species extinction decreases the species richness on Earth. So when we look at this, we can see that this right here, this little dash line, is the background extinction rate. And so pretty much everything that we are measuring right now is much higher than that background extinction rate. The next indicator we can look at is food production. So this is just indicating the ability of our soil, water, climate to support agriculture. Some major threats to food production are going to be climate change. As it gets warmer, we see the soil drying out. So it's less suitable for agriculture, soil degradation, so desertification, not enough water, topsoil erosion, and groundwater depletion. All of these things are going to make it very hard for us to produce enough food to support the human population. You can see this diagram here shows you the projected impact of climate change on agricultural yields. You can see that's really going to be concentrated there near the equator, so southern United States, South America, Africa. You can see those red areas show that there's a projected 25% decrease in agricultural productivity. So that's a pretty big change. Another thing we look at with food production is increasing meat consumption. That puts a further strain on this food production. It takes away water and land from grain production. And when we talk about grain, this one is a really good indicator of whether we're doing well with being sustainable or not, because this grain production, when we look at it, it's per person. Okay, so it's kilograms produced per person, and it's really started to show signs of either leveling off or even declining. You can see it peaked in the mid to late 80s, but since then it's just it's had some ups and downs, but it's not doesn't have this nice continuous upward trend. Okay. And that is a super negative thing, because around 2 billion people here on Earth rely on rice for their main nutrition, and rice is a grain. So we are not producing as much grain per person as we were able to in the past, which can be attributed to population growth. And then also these threats like climate change, soil degradation, groundwater depletion, which are all going to reduce our yields from our crops. And then this is probably the biggest one we look at, is atmospheric temperature and carbon dioxide levels. And it's super important because life on Earth depends on a very narrow temperature range. It can't be too hot, it can't be too cold. So when we look at carbon dioxide, we know it's a greenhouse gas, which traps that infrared radiation. So we receive solar energy, and then the Earth itself releases infrared radiation, which actually causes the warmth. And we've got that little blanket of our greenhouse gases all around Earth. You can see some of that heat gets to escape, but quite a bit of it gets trapped here and sent back to Earth. So increased carbon dioxide results in higher temperatures. There's no way around that. It's scientifically proven. If you look at this graph over time, you can see that as the parts per million of carbon dioxide increase, the temperature is also increasing. Some other things that can cause this carbon dioxide level to rise, we've talked about deforestation, so that's going to have decaying trees releasing carbon dioxide, loss of sequestering sources for carbon dioxide. burning fossil fuels, so combustion of fossil fuels, emission, that releases carbon dioxide to the atmosphere. So when we do that, we see these higher temperatures, which is going to dry out that soil. So we have to draw more water up to water our crops. And this just makes it very unsustainable to farm. It's also going to destroy habitats and even worsen storm intensity. So as the human population is growing, resource depletion grows. That really should make sense, guys. When we look at the graph, this is one of the extreme examples of exponential growth. You can see human population is just skyrocketing. And the more people there are, the more resources we need to support those people. So when we have resources that are harvested unsustainably from a natural ecosystem, that's going to degrade ecosystem health. So organisms aren't going to continue to live there. So whenever we need resources, that could be paper. That's going to lead to deforestation from the lumber. If we need more food, that's going to lead to things like soil erosion, deforestation to plant more crops, groundwater depletion, because we're pulling way more water out to be able to water our crops. More travel, as people are starting to travel more and more, we have to have the fuel to run however we're traveling, whether we're flying or driving or whatever. So that's going to equal more fossil fuel mining, which is going to equal air, water, soil pollution, and habitat destruction, even to build like highways or airports, things like that. So this graph is showing you that there. You can see our purplish line is deforestation, orange is population. So as the population increases, the amount of resources that we're using also increases. So for our practice FRQ, you're going to look at this table here, and you're going to explain which student most likely lives in a highly developed country, and you're going to describe how one of the 4 categories of ecological footprint can serve as an environmental indicator. Okay? All right, so this last section, we're going to go back kind of to thinking about that urbanization, and we're going to look at ways to reduce urban runoff. Urban runoff and stormwater runoff, they're the same thing. So if I say stormwater runoff, that's what I'm talking about. We're going to look at the problems that are caused by urban runoff and how to mitigate those problems through things like rain gardens. So here's your essential knowledge, your learning objective. And the last thing I wanted to point out on this slide before we moved on is the word mitigate itself. Mitigate just means to reduce the impact. So remember AP, when we start taking those that exam, having those higher level vocabulary words is a good tool to have in your pocket. Okay, so mitigate equals reduce. So let's start with the environmental consequences of urban runoff. And the biggest one here is decreased infiltration. So groundwater recharge is decreased in urban areas. We've already talked about this. You've seen this. So rain, and I mentioned it before, rain's going to wash those pollutants then into storm drains and into local surface water. So you can see this is a really good graphic here that shows, you know, in a city, you can have anything from oil and gas, trash, gas, pesticides, hydraulic fuel, even sediments from construction sites. And as it rains, that rain is going to carry all those sediments to this storm drain. And a lot of times those storm drains are going to enter directly into a local body of water with no treatment. My husband actually works in stormwater. He makes sure that construction sites are not releasing too many sediments into the drains, which will then increase the sedimentation and the turbidity of the local waterways. So some effects of these different pollutants, especially in this one here, is especially in northern areas. When it's cold, they put salt down. So as the water runs, it's going to pick up all the salt and take it to the water. And that can lead to plant and insect death. Sediments, that's going to increase the turbidity. So Once again, it's going to get in fish's gills. It's going to make it hard for them to breathe. Not as much light can get through, so not as much photosynthesis can happen. When those fertilizers end up in the water, we can see that eutrophication and those algae blooms, which then cause hypoxia. And then pesticides, if they get into the water, they can kill non-target species, so other organisms living in the water that we didn't really want to kill. And then oil and gas can actually suffocate fish and kill aquatic insects. So quite a lot of consequences of this. So let's talk about some solutions. The first solution is what we call permeable pavement, which is just specifically designed pavement that allows stormwater to infiltrate through it, and that allows the groundwater to be recharged. So when I say permeable pavement, that's just pavement that has these pores in it that's going to allow the water to actually drip through instead of just running off. This is going to decrease runoff. It's going to decrease pollutants that get carried into stormwater because the water is not going to the drains, it's going into the groundwater. It's also going to decrease the likelihood of flooding during a heavy rainfall because the water has someplace to go. And then a downside of this, though, is that it is much more costly than traditional pavement. The next solution we're going to talk about is what we call a rain garden. So gardens, all a rain garden is a rain garden. Wow. All a rain garden is a garden that's planted in an urban area, typically around a storm drain. So storm drain there. And so what you're going to see happen is you're going to see less runoff because there's going to be these plants here. There's going to be soil. The water's going to infiltrate down into the soil instead of going to the storm drain. You can see here that water is being kind of channeled into that rain garden and not flooding the road. This is also going to create habitat for pollinators. It's going to create what we call that sense of place, a more homey feeling. And if we're planting trees in these gardens, that's going to store carbon dioxide. So next solution would be public transit. More cars on the road equals more pollutants on the street. This is a really good diagram here. You can see this group of people right here take up all that space if every single one drove their own car. But if same amount of people were to ride a bus, much less traffic. So when we're talking about those pollutants that come from cars, that could be things, anything from motor oil to pieces of your tire to gas to antifreeze. The other thing to think about, more cars equals more lanes and more parking lots. If we have a lot of traffic, we have to have more lanes. That's more impervious surfaces. More parking lots equals more impervious surfaces. And we know that equals more runoff. So public transit is going to be able to decrease runoff, decrease the pollutants on the road, decrease carbon dioxide emissions because we just need to power this bus instead of every single individual car. And it's even going to decrease traffic. This is just a little kind of like a cheeky graphic here. It says you are not stuck in traffic, you are traffic, okay? So you can see all that traffic because of all these people driving their own car. But if you're in the bus, not as much traffic. All right, next, building up, not out. So that just means building vertically, like building skyscrapers instead of a bunch of individual small buildings. So this is going to decrease impervious surface, which we know decreases runoff. This diagram is pretty interesting. It compares Atlanta to Barcelona. They both have about the same population. Barcelona's is actually a little bit bigger than Atlanta's. But when you look at the urban area, there's over 4,000 square kilometers of urban area in Atlanta, but only 162 square kilometers of urban area because they have grown up extremely well. And then when we look, I think one of the most interesting things to look at here is the carbon emissions from transportation. If you live over here in Atlanta and work over here, you cannot walk, okay? You can't get there by walking. But in Barcelona, it's a much more walkable city, so they don't have as many people commuting. So when you look at that number, they don't even they don't even have 10% of their carbon dioxide emissions per person coming from transportation. Okay, so when you look at the total amount of carbon dioxide that every person is responsible for each year, less than 10% of that per person is from transportation. So it's pretty good. So we can combine this idea of building up, not out, with a green roof or rooftop gardens to further decrease runoff. They also sequester carbon dioxide, filter air pollutants out, because we know plants can absorb that carbon dioxide. They can absorb all kinds of things like particulate matters and other pollutants and store those in their tissue or their soils instead of us breathing them in. And then this is kind of a longer FRQ today, but these notes weren't too long, so I think you can do it. For this one, you're going to design an investigation to measure the relationship between the number of trees in a city and the amount of stormwater runoff the city produces. So if I wanted you to go into a city and determine how does the amount of trees relate to the amount of stormwater runoff, how would you do it? Okay, so the first thing you're going to do is propose a hypothesis. So you need to think about, if I increase or decrease my independent variable, then my dependent variable will increase or decrease because of that. So write a hypothesis, outline a procedure. It does not have to be super detailed, guys, okay? For this right here, just tell me what you would do. Identify your independent variable and identify your dependent variable.